Hello everyone. Today we will be doing Spark-based, Naive-based classification on the KDD Cup 1999 data. This will be an analysis of distributed computing on HDFS cluster. So the KDD Cup 1999 dataset is a very well-known dataset in the field of network intrusion detection. So this dataset has values that can be used to classify whether a network connection is normal or an attack. The naive Bayes is a popular machine learning algorithm used for classification tasks. Apache Spark is a distributed computing framework that provides fast and efficient processing of large data sets. And in this project, we have used Spark based naive based classification algorithm to analyze this KDD Cup 1999 dataset and detect the network intrusions. We've used an HDFS cluster, a Hadoop distributed file system cluster, which is used by Hadoop applications. This provides high throughput access to application data. HDFS is designed to store and manage large data sets across a cluster of commodity hardware. The HDFS architecture has a single name node called as master node with its own resource manager and multiple slave nodes which are called data nodes with their node managers, and each of these slave nodes will be running the map reduce of Hadoop. Now let's see how to set up our name node, our cluster. So here, as you can see, we will use the start dfs.sh command. Here we can see that our localhost 9870 has started running. Next, we will start the yarn, start-yarn.sh, and it will start the resource manager and node managers. Now you can see the HDFS file system. Here you can see the yarn application manager. So we have two active nodes in our cluster right now, and this is our HDFS. Inside this user Hadoop folder, we can upload any files that we want, and these files will be distributed across the whole cluster. So now I will show you how to upload a file to the cluster. So here I'll be creating a txt file. So this file will be sent from the master to the slave nodes using HDFS. So here I have created this file, and let's just save it to the desktop. I will name this file testfile1.txt. So now to put this file on the HDFS, we will use the Hadoop fs-put command, and we will give the path location of the file and also the location where it has to be saved in the HDFS. So here, as you can see, we have used Hadoop fs-put test file 1, and it has come in our HDFS. When you reload the HDFS, you can see this file which is called test file 1. And now we'll look at the slave node. So this is our slave node where we can see the Hadoop master, and here also we can browse the HDFS, and inside that same user Hadoop folder we can see our test file 1, and then we can download it. And as you can see, this is the same file that has been sent from the master node to this slave node. So that is how the HDFS cluster works, where you can transfer files and they will be distributed across all the data nodes in our cluster.
So now I will talk about the Apache Spark. So what is Apache Spark? It is an open source distributed computing system designed for big data processing and analytics. It provides a unified framework for batch processing, real-time streaming, and machine learning and graph processing. So what are the advantages of using Apache Spark? Speed, that is Spark's in-memory processing capability significantly improves the speed of data processing compared to traditional disk-based systems like MapReduce. Ease of use, Spark offers high-level APIs in multiple programming languages like Scala, Java, Python, R for developers to write complex data processing tasks with simplicity. Also scalability, which you can see Spark can scale horizontally across a cluster of machines, allowing it to process large data sets efficiently. Now let us talk about the architecture of the Apache Spark. As you can see, there is a driver program and the cluster manager, which is managing the responsible for allocating resources like CPU, memory, and managing worker nodes in a cluster. These worker nodes are responsible for executing the tasks assigned by the driver program. They store data in memory or disk and perform computations on distributed dataset. Now let us talk about how Apache Spark can be run on the top of the Hadoop cluster. As you can see, Spark on different cluster managers. Apache Spark can run on various cluster managers, including Hadoop Yarn, Apache Mesos, and Kubernetes. By running Spark on a Hadoop cluster, you can leverage the existing Hadoop infrastructure and take advantage of its data processing capabilities alongside Spark's advanced analytics features. Spark can run in standalone mode without relying on any cluster manager. In standalone mode, Spark's built-in cluster manager is used to allocate resources and manage the worker nodes within the same cluster. It provides an easy way to set up and experiment with Spark without the need for external dependencies.
So, today I am going to talk about the Naive based algorithm, one of the most popular classification algorithm used in machine learning. It is a probabilistic algorithm that's used for various applications like spam detection, text classification, and sentiment analysis. Bayes theorem is one of the theorem used for this classification. The formula P of A by B is equal to P of B by A into P of A divided by P of B is the Bayes theorem, where A and B are the events. P of A is the prior probability of A, and P of B by A is the conditional probability of B given A. Which is a way of calculating the probability of an event based on prior knowledge of related conditions. Now, let us understand how the naive Bayes classification works. It assumes that the features are independent of each other, which means that the presence of one feature does not affect the presence of another feature. So, the algorithm calculates the probability of each feature, giving a class label and multiplies them together to get the probability of a particular class label. Let us take an example. Let's say we want to classify an email as spam or not a spam. Based on the presence of certain words, the naive-based algorithm will calculate the probability of each word, given the class label, and then multiply them together to get the overall probability of the email being spam or not spam. There are different types of naive-based algorithm such as Gaussian, multinomial, or Bernoulli. Now let us see the applications. Here are some applications: spam filtering, sentiment analysis, document categorization, recommendation systems, and etc.
So now we'll start the running the algorithm. So to implement the naive based algorithm in Spark ML, we have a few steps that we'll need to follow. Firstly, best thing about Spark is that it can handle large data sets, so we don't need to worry about the size of the data. Next, we need to prepare the data by splitting into training sets. After preparing the data, we need to vectorize the data. Spark ML requires that data represented as vectors. Now that our data is ready, we can create naive based instances and set the parameters, and then we can fit the model using training data. Finally, we can evaluate the model's performance using the testing data. Now we will run the command on the cluster using the Spark. As you can see, this is the output that we have got here. This is the Spark history server where we can see all the running jobs, and here are all the active nodes which are doing the task. Now we'll show you the code. And here is the data which is there in lib svm format that we have used to execute. And this is the code that we have used to train our data. This is the history server for the Spark on the slave node where we can see all the applications running and run yet and are running on the cluster. So as you can see, this is the results we have got. We can see the label part and the features and the raw prediction that we have got and the probability and the predictions we have got. We have, as we can see, we have got the 692 features and the predicted labels are binary, which is 0 or 1. So now we have come to the conclusion. Naive Bayes is a popular machine learning algorithm used for classification problems. It's a probabilistic algorithm that makes Bayes theorem to calculate probability of data points belonging to a certain class.
Nave base has proven to be highly accurate in a wide range of application and is also computationally efficient, making it a popular choice among the real world problems. Thank you, and thank you for listening to us. That's all from our side.